Okay, so this is the first law of thermodynamics, and in this tutorial we shall see about the origin and how we define the first law of thermodynamics. So before going to the topic first law of thermodynamics, we shall see about how we define the subject thermodynamics, or to be very specific, what do you mean when we say the subject thermodynamics. So thermodynamics is the subject of how we convert heat into work. So in the subject thermodynamics, we deal with how do we convert heat into work. Okay, so here I have defined two terms, heat and work. So what is heat? Heat is nothing but the sensation of temperature. You know, in the earlier times, people used to think that heat is some kind of fluid which is called as caloric, and it was assumed that it is that caloric which when flow through one body to another, the body gets cooler or hotter according to the this flow of caloric. First law of thermodynamics, the heat which is flowing from one body to another body, let me write it as del Q. Here del is nothing but a change in heat. This heat flow should be equal to the change in internal energy plus the change in work done. So it is the first law of thermodynamics, and this equation also says about the energy conservation. Here U is the heat which is being transferred to a body or taken out from a body. Here U is the internal energy, which is the energy possessed by a system, and W is the work done. Point to be noted that this heat depends on the path, so this Q is a path function. This W is also a path function, and this U, which is the internal energy, it is a point function. Okay, so in thermodynamics there are various processes, and we shall see one by one that what are those processes, and we shall calculate accordingly the work done, heat absorbed, and internal energy in the processes. So the first process is called a isothermal process, and in this isothermal process, the temperature of the system remains constant. So here temperature remains constant. So let us now calculate the work done. So the work done in an isothermal process is, as we already know, that the formula for work done is nothing but P dV. So we shall now change this P, as we know that for an ideal gas PV equal to nRT. So we change it as nRT dV by V. Okay, so nRT, so N is the number of mole which is constant, R is the universal gas constant, and T is the temperature which is already constant, so we shall take this term outside. nRT integration dV by V, which is nothing but nRT ln V. So the work done in an isothermal process is nRT ln V. Okay, so what about the internal energy? So as the temperature is constant, the internal energy shall also remain constant in an isothermal process. Okay, what is important?